All right, if you're a software engineer, there is one giant question that has probably been on your mind lately. How is AI really going to change our jobs? And I don't mean the hype. I mean the day-to-day, hands-on keyboard reality of what we do.
I mean, you can't escape headlines like this, right? They're everywhere. And let's be honest, they're designed to get clicks and make us all a little anxious. They paint this picture of a revolution that's here to automate away the very craft of programming. It's just creating so much noise.
So the real question is, how much of this is just sensationalism, and what is the actual practical reality for engineers on the ground? Well, that's what we're going to dig into here. We're going to cut through that noise, using insights from some of the industry's sharpest minds to separate the hype from what's really happening.
Now, this whole AI moment feels completely new, right? Like nothing we've ever dealt with. But it turns out we can find some really powerful parallels if we look back at the history of software. And looking back might just give us the clearest view of where we're headed. The brilliant software architect Martin Fowler, one of the authors of the Agile Manifesto, makes this incredible comparison. He says that the AI shift we're in right now is as big as the move from assembly to high-level languages. Think about that for a second. That's a change so fundamental, you have to go all the way back to the dawn of our profession to find something like it. And this timeline really puts it into perspective. In the early days, everything was assembly. Then, bam, high-level languages like Fortran and COBOL showed up. And that was a monumental leap in abstraction. And now, here we are, stepping into this third major era, AI-assisted development. So clearly, this isn't the first time our jobs have been completely reinvented. So what did that first big shift actually feel like for developers? Well, they went from thinking about tiny machine-specific instructions and managing memory by hand to thinking in abstract logic, loops, functions, conditionals. The compiler handled all the gritty details. We basically moved up a ladder of abstraction, and that is exactly what's happening all over again.
But here's where the analogy gets a fascinating twist. Because while we are making another jump in abstraction, Martin Fowler points out that the most profound change AI brings to the table is something entirely new, something we've never really dealt with in our day-to-day work.
This right here gets to the absolute core of it. A compiler is deterministic. You give it the same code, it produces the same result. Every single time. Our entire tool chain, from our unit tests to our debuggers, is built on this bedrock of predictability. AI comes along and just shatters that assumption.
So what does non-determinism mean? Simply put, it's uncertainty. It means you can give an LLM the exact same prompt 2 times in a row and get 2 completely different answers. It's like working with a tool that kind of has a mind of its own, and that fundamentally changes our relationship with the code we produce.
So that leads to a huge question. If the tools we count on are no longer perfectly predictable, what does that actually mean for us? What are the real-world implications for how we learn our craft, how we debuild our systems, and how we build things that are reliable?
Well, this new uncertainty puts one of our most fundamental processes at risk. And this process is the absolute foundation of how we get better, how we gain real mastery as software developers.
I'm talking about the traditional learning loop. It's simple, but it's incredibly powerful. You have an idea, you write the code to make it happen, you observe the result, and then, this is the most important part, you learn why it worked or why it didn't. This tight, constant feedback cycle is literally how you improve.
But AI introduces a massive risk here, something Martin Fowler calls vibe coding. This is when you just take the code the AI generates, you run it, it seems to work, but you don't deeply understand it. You've completely short-circuited that learning process. You got a result, sure, but you skipped the why. You didn't build a mental model, which means when that code inevitably breaks down the road, you are completely lost.
Okay, so we've got this fundamental shift in how we work, but how is it actually impacting productivity out there in the real world? It's time to move past all those sensational headlines and look at what the hard data is actually telling us.
The hype promises these incredible gains, right? You see claims that AI is writing 30% of all new code. But as CTO Laura Tacho points out, a lot of these numbers come from really misleading metrics, like just counting accepted suggestions. We need to dig a whole lot deeper than that.
Let's take a real-world example from Booking.com. They did a huge company-wide push to get everyone using AI tools. And what happened? About 65% of developers were using them weekly. Now, that's actually pretty high, but it also shows that even with a massive effort, a huge chunk of engineers, 35%, are not regular users, and often for very good reasons.
So if counting lines of code or accepted suggestions is a bad way to measure things, how should engineering leaders actually figure out the return on investment for these expensive AI tools?
We need a better framework.
And Laura Tacho proposes a much more sober, realistic framework for this. It moves the whole conversation away from vanity metrics to what actually matters. It asks 3 key questions. 1. Utilization. Are people even using the tool? 2. Impact. Is it making things better in ways we care about, like shipping code faster or improving developer experience? And finally, 3. Cost. What are the real trade-offs, from the price of the license to the cognitive load of reviewing all this unpredictable output? This is how you measure true value, not just noise.
All of this leads to a really powerful conclusion. Despite all the hype, the most valuable, the most complex, and the most difficult parts of software engineering are not being automated away. In fact, they're becoming more important than ever.
And Martin Fowler gives us the perfect mental model for how to work with AI. He says, treat every slice of AI code as a PR from a rather dodgy collaborator. It's perfect, right? It's someone who is incredibly productive, but you absolutely cannot trust a single thing they do. You have to review everything with intense scrutiny, just like you would with a pull request from a brilliant but kind of erratic junior developer.
So, if AI is going to handle more of the boilerplate, what skills become even more valuable? Well, it's the uniquely human ones that AI can't even touch. It's the critical thinking to rigorously vet a piece of code, not just accept it. It's the communication it takes to talk to a product manager and understand the real problem we're trying to solve. It's the wisdom to balance complex business and technical trade-offs. And it's the empathy you need to mentor the next generation of engineers. These are the things that create real value. So, the big takeaway here is this. AI isn't your replacement. It's just the next powerful tool in a long line of tools that have elevated our work. Just like compilers freed us from thinking about hardware registers, AI is going to free us from writing tedious boilerplate, which lets us focus on the much harder, higher-level challenges of system design and problem solving.
So no, this tool isn't coming for your job. It's more like a new team member, a tireless, brilliant, yet completely untrustworthy intern. And so the real question for all of us is, how are we going to manage it?